So yes, this is going to be our DIY Macropad project. And this has kind of been a pet project for Will and I, and we were lucky enough to be able to bring this to all of IEEE. And you're actually going to be hearing from Will a lot more than you'll be hearing from me tonight, which I'm sure is a relief for some of you hearing me ramble on at all of these workshops. So you can see in the picture here, this is what our final project ended up looking like. This is the final product. And of course, on the back, I think it was the first slide in Mike's presentation, you could see the big sponsored by Roden Schwartz on the back. We did not forget those guys. But I'm going to be turning it over to Will here. Yeah, showing it on the back. I'll be turning it over to Will here, and he's going to talk about a little bit of the background, a little bit of the development process, and how we got to this part. And then we'll go ahead and build it in a little bit. So Will, I'll turn it over to you.
All right. So if you could head to the next slide, sorry. So we'll start off with what is a Macropad. Not everybody knows what a Macropad is. So a Macropad is normally a set of keys that perform some set of functions. So for example, your computer keyboard is kind of a very basic Macropad, but Macropads are special because you can do multiple things with one key press. So for example, you could have one button be programmed to do Control and C at the same time to copy, and then a different button could be Control and V to paste. Or you could have one button open up Google Chrome and go to google.com or something like that. You can automate a lot of stuff with a Macropad. If you are familiar with a Stream Deck is a very specialized type of Macropad developed mostly for streamers and that sort of thing. But yeah, it's just a very flashy type of Macropad. Go to the next slide. So how are we going to interface with our computers using this little thing we made? So there is an Arduino board called the Pro Micro. It was developed by SparkFun and sort of adopted into the Arduino ecosystem. It is the most widely available board in the Arduino ecosystem, which has HID support. HID stands for Human Interface Device, and that's just a standard so that computers know how to deal with mouse keystrokes and keyboard keystrokes. So it's just the protocol that tells the computer that the space bar has been pressed or the escape key has been pressed. And the Pro Micro natively supports sending these keystrokes and mouse strokes. And so we use that for our Macropad here.
Yeah, so to jump in, if anybody's familiar with the Arduino kind of development environment and stuff, this is kind of a big deal because most Arduino boards, most of those microcontroller boards that are popular actually don't have this kind of support baked in. So we originally were going to try to find a different device to do this. And I know we have kind of this goofy thing down here. I need a more user-friendly computer. And then the computer says, I need a smarter human. Unfortunately, we're kind of going back and forth in that way when we were developing this. And we settled on, if you guys have the kits, they're going to be these little chips here, rather than the Unos that most people are familiar with and they kind of associate with the Arduino ecosystem. So going forward, whenever we talk about the Pro Micro or the microcontroller that goes into this, one of these little guys is what we're actually talking about, just so you can visualize that for people that don't have kits on them right now.
Thank you. Okay, so our original prototype, and I have it here, you can probably see it better on the slide there. It was very simple. It was 4 computer keyboard key switches that were hooked up to 4 pins of an Arduino Pro Micro. We would program the macros that each key would activate using the Arduino IDE. So you can send keystrokes and mouse movements through the Arduino IDE if you're using a Pro Micro or a different Arduino board that has support for HID. But this was not ideal, mostly because it was really hard to program, because every time you wanted to make a new set of macros for your keys, you would have to write an entirely new Arduino file. We tried to automate this using a Python script that you would put a simplified version of the macro through, and then it would make you a .ino file that you could upload. But even then, the scope of the macros you could do was very limited. You couldn't do as much as you could do with different solutions, such as QMK, which we'll talk about on the next slide. So QMK. QMK stands for Quantum Mechanical Keyboard. It's kind of last in the line of a lot of older mechanical keyboard firmware builders. But QMK stands out because you can do a lot of really powerful stuff with QMK made firmware. So layers is a big part of QMK. So if you've ever hit the shift key on your keyboard, you know that that goes to kind of a little different keyboard, which is all uppercase. You can think of the shift key as a sort of layer switch that switches to all uppercase. QMK expands on that and says, hey, what if it wasn't just uppercase letters? What if it was completely different keystrokes that you could send? So for example, on my keyboard, I have it so that if you hold down the caps lock key, the H, J, K, and L keys become arrow keys. Or even you could have a button that switches to a layer which is full of a bunch of macros, like Control-C, Control-V, open up Chrome, that sort of thing. QMK is really popular when it comes to enthusiast keyboards because it's very, very customizable. Down on the bottom right, you can see a picture of the OLKB Prionic, which is a popular enthusiast keyboard, which was one of the first to use QMK. QMK is relatively new, kind of came about in the 2015s. But you can see down at the bottom, there's a kind of a weird stubby looking space bar, but to the left of that, there's those two orange keys. Those two orange keys in this layout are being used as layer switches. So they would, with their thumb, hit one of those keys to switch to a layer that has maybe a bunch of macros or arrow keys or whatever they wanted that other layer to do. You would build the QMK firmware with an online tool made by QMK, and then it would be uploaded using some sort of software such as QMK Toolbox, or in certain cases, AVR programmers, like if you are using a Pro Micro. That's it for QMK.
Oh, forgot I was muted there for a sec. So I will take over kind of talking about the circuit design aspect of this, because QMK, because it is designed to be a reconfigurable piece of basically firmware at this point, we have to design a circuit that can be just as flexible as the software and firmware that we're putting onto it. So most keyboards will actually not use a matrix like the one that you see here. So we had to design this matrix of key switches and diodes. I say design very loosely because there are a lot of reference guides and stuff online, especially on the QMK wiki and some of their reference designs on the boards. So this matrix of key switches and diodes is a different way. I won't get into all of that right now, but it's a different way to be able to sense inputs on the Pro Micro. So it'll be this microcontroller that you see here. I'm not sure. Can you guys see where my mouse is on screen? Okay, Will's giving me the thumbs up. So yeah, if we're looking at this block here where it says SparkFun Pro Micro, you can see a bunch of pins coming out on the left side that give us our rows and columns. So essentially, we have to tell the QMK firmware which pins on the Pro Micro correspond to each row and column of this matrix. So in our setup, we did this with that online firmware builder that Will had talked about, and we'll take a look at that in a few minutes. But there are also a couple of other optional pieces of functionality that we can add into this just by changing a few parameters. So one of the cool things that we were able to add to this was lights that go in the key switches. So you have kind of that nice little underglow whenever you're typing. You can kind of see the keys better if they might have like a clear top to them. So I know like on my keyboard, it's a little bit gamery, but I can see the light kind of shining up through the keycaps, and it just helps you to kind of see, especially when you're clicking around in the dark. So if we're taking another look at this circuit here, you'll also see that there are a couple of elements off to the side. So this J1 jumper is actually just a reset and ground pin thing that's exposed. That's what we're going to use to reprogram this. It basically just tells the Pro Micro like, hey, we're going to enter into a mode where we're going to be accepting some input from the computer to tell us how we want to reconfigure all of the pins. There's also a little section over here that has a MOSFET. In our most recent design, we designed this for a different type of MOSFET than what we had purchased. So tonight's build is going to be a little bit of a workaround for that. I think I need to go back to EE 310 and remind myself of how P channel and N channel MOSFETs and all that technology works, because it's been a couple of years. I'm a little bit rusty. So I'll hand it back over to Will, but just so you get the general design here. Also, if you're super curious and want to delve into this, I designed this in Eagle, and all of the design files and stuff I'll be uploading whenever I upload the recording of this video. So if you want to get your hands on this and kind of dig around, you're more than welcome to, and I'll make sure to post a link once I upload this video to YouTube. Actually, moving on here, before I turn it back to Will, this is what the board looks like in its raw state when you have it in Eagle. It's really nice, and with the boards, for those of you who have boards, you'll be able to see kind of a little bit of an outline around where the key switches go. But in the software, it basically gives you guides depending on the footprints that you import. And so these guides spaced everything for us. And like I said, I use design very loosely, because QMK and the community behind the software do an excellent job at documenting and providing you with resources to build your own one of these. So although it kind of seemed like a daunting task whenever Will and I started this back, in October or November now, once you get into it, there's really not a ton of work that you have to do other than making sure things are wired together properly. But yeah, just kind of a behind the scenes of what this looks like. And again, all of these design files will be available to you once the recording is uploaded. So I'll stop here, and I'll ask if anybody has any questions so far. I know we haven't gotten to the build part of it yet, and so many people here are probably anxious to get to the build part. But any questions so far about, our design philosophy, our kind of intentions for this, how we used Eagle? Seen a bunch of stares. Okay. I'll take it that everybody's following along perfectly then. All right. Yep, I'll turn it back over to Will, and he will talk about more of the software side of things.
Great. So quick overview of the entire board. It's just a 2x4 switch matrix. We had to make a custom key map and custom pin setup. Ethan, if you could go to the next slide. The next slide is going to be, here it is. This slide just shows the firmware, not the firmware, excuse me, the kind of layout portion we were talking about. We used a separate online tool to make that layout that we would import into this firmware builder, which you guys will be using when you program your Macropads. But you can see this is kind of for a more standard looking keyboard with the number pad and the arrow keys. And you can see the connections here. The lines are the connections between the columns and rows, and then the gray lines are like they would be the diodes in the circuit here. But we have to keep in mind when we're designing which pins from the Pro Micro are going to which column, which row, and that'll really come in very important when we give more information to the firmware builder a little bit later. But if you go to the next slide. So yeah, I mentioned we made the layout for QMK with a different online tool, and then using that layout, we'll import it into a firmware builder. Most of you, if you're using Windows, and I believe Mac as well, you are going to be using QMK Toolkit to program your Pro Micro. Actually, if you look on the right, on the picture there, you'll notice that doesn't really look like a Pro Micro. That's actually an Elite C, which is a drop-in replacement for the Pro Micro that has USB-C and a much sturdier connection than some of the Pro Micros do. Yeah, but it's you can think of it as effectively the same. If you're a huge USB-C fan like me or Ethan, you can buy one of those online and just program it in the same way. You'll also notice some of you may have yellow key switches, but the one in the picture are brown. Different manufacturers, and even within the same manufacturer, they will make different types of key switches, all in the same footprint. So the one you see on screen are browns. They have a little bit of tactility. Some of you may have yellows. Those are very smooth. There's no tactility. If you're a huge keyboard nerd, you may have heard of blues or reds. They're just different key switches with different characteristics. If you have a very clicky keyboard, you probably have blues. Yeah, just different key switches, all do the same thing, all can fit in the same footprint, but they just feel a little bit different. We give you the choice between browns and yellows.
Yeah, and I'll be honest, I didn't really understand the difference until Will started telling me all about his keyboard wizardry about a month and a half ago. And the only experience that I had of these different key switches was going into Best Buy and, you know, clacking out in the gaming keyboards or like the keyboards that they have on display there, and, you know, them making those crazy clicking noises. I've always just been using like either the Dell standard stuff that you get with your towers, or, you know, I finally invested in something that's close to acceptable for Will not too long ago. But yeah, I mean, do we have any people on the call that are keyboard enthusiasts, or is this more of just kind of like a side interest for anybody? I'll take that as a no. So you all are about on the same level that I'm at. But hopefully, you know, if you have any more questions, I'm sure Will can answer them. Like I said, he's got his keyboard wizardry and all that stuff going on. So
I also
now,
just wanted to point out right before we get to assembly, you might notice that on your switches, they kind of taper out a little bit to the center. Sorry about the motorcycle, if you can hear that. So switches aren't normally mounted like this directly onto the PCB. They're normally actually clicked into a frame, and then the PCB kind of floats underneath. We weren't really able to get to that point with this. We hope to get in maybe a later revision, something like that. But just know that this is a little strange for a keyboard or a Marcopad.
Yeah, sorry, my video just died, but hopefully you all are still able to hear me. We're going to be moving on to the assembly portion in just a moment. I'm going to go ahead and get my setup ready, and I would encourage all of you to do the same. So what you can do now is go ahead and take out your kit and spread everything out a little bit. I would recommend leaving the diodes in the smaller diodes and the resistor, and then the LEDs in their baggies right now, just so you don't lose them. And if you do lose them, just let us know and we can go ahead and get some extra parts to you in the next day or so. But yeah, just give me a couple of minutes here to get my camera back online so you guys can see what the heck I'm doing. And we will start on the assembly process.
While Ethan is setting up, do we have any questions before we start the assembly about anything we've covered in the presentation? Okay, well, if you do end up having any questions during assembly and you don't want to unmute yourself, feel free to put it in the chat. Let me check the chat. Will, what's your favorite keyboard? I'm using the Drop Alt, very lighty uppy. I really like it because you can actually switch out what key switches are on it. Give me your Mount Rushmore of keyboards. The Preonic up there is pretty cool. Oh man, Mount Rushmore of keyboards. There are some expensive keyboards, like people that machine like hunks of metal to be their like 10-pound keyboard, and then they lube up their key switches, real nerds about it, and they can be like $10,000. So How's that for a Mount Rushmore? Wild. Drop keyboard recommendations. I'm a big fan of my keyboard right now. Drop Alt. I'll put it in the chat. I could give a whole presentation on just really dorky keyboards. Okay. Thanks for saving me, Ethan. It looks like he has his camera ready.
Yeah, I finally have this up and ready. I'll save Will from answering all, but my goodness, Paul, I didn't know you were such a gamer. Or is that your son's keyboard?
Oh, I missed it.
So that's my son's keyboard, but I did the research for it about a year ago.
There we go.
I think he's actually moved on from it into something better. Limited production,
Oh, wow.
Fancy. All right. So, you know what? You got gamers all over. And you know what? Not even for gamers. I use the macro keys on the side of mine for content creation. So a lot of content creators, or like in Eagle, I have a couple of hotkeys that can switch between views for me. So that works out pretty nicely. So there, it's not just one specialized niche kind of thing. There are plenty of ways that you can actually use this technology, and especially the one that we're making tonight, to kind of adapt to different programs. So, if you do a lot of design work, you can set it up for your design programs. Or if you end up just playing some CS:GO on the weekends, that is perfectly fine. So we will start out kind of looking at some of the materials that we have out here. I guess I can zoom out ever so slightly. So a few things that you'll notice in your kit, and if you don't have these, please let me know. So the few main things are, I guess I'm now out of frame. Here we go. So, and you also might want to pin my video if you have not already. So a few of the things here we have here are, of course, the printed circuit board for it. Is this upside down for everybody? Oh gosh. All right. This is going to be a little bit trippy. So the first thing that you'll have is the printed circuit board, and you can see some of the logos on here. So starting from the left and moving to the right, this is the open source hardware logo. And as we move over, of course, Penn State QMK. So this is the firmware that we're going to be using. And then most of the keyboards, the custom keyboards, will have a cutesy little name with it. So Will and I figured, this is pretty small and it only has 8 keys, so we named it the Pluto 8, and got a little planet logo in there. But because this is open source hardware, like I said, all of the design files and the especially the firmware is going to be open source, because QMK is open source as well. But all of this is going to be documented. Will had mentioned a gist. If you guys don't know what that is, it is basically a Git repository of sorts for instructions. So this QR code, if you scan it on your device, will take you to that gist, and it has all the setup instructions. So you could go ahead and do that now, or Will, if you would not mind posting that in the chat, just so that they have that. So I don't believe the design files are on the gist quite yet, but they will be in the next few days. So that's the front. And then looking at the back, of course, we got our nice Roden Schwartz logo. Shout out to you guys again. And you'll see also up here, we've got some reset and ground pins. Those are going to be important for programming later, so just keep that in mind, that these are up here in the corner. So first and foremost, go ahead and set everything off to the side carefully. You definitely do not want to lose any parts. But we're going to be taking out the diodes here, and we're going to be building that little diode matrix. Luckily for you guys, it's already set up and integrated onto the PCB. Oh, I just realized I am hitting the A key on my keyboard here. I didn't want to spam chat with a bunch of A's. So yes, go ahead and take these out of the baggie. You're going to see there's going to be 1 resistor and 8 diodes. Like I said, if you do not have all of those materials, please let us know, and we'll get you more materials as soon as possible. And then also keep in mind that diodes are directional devices, just like LEDs, which are light emitting diodes. So they're only going to go in one way. You'll notice on the printed circuit boards, one side of these diodes has what looks like a little bit of a line. Let me see if I can get a bit of a close up here. So you'll see it'll be on the bottom side of the footprints there. And on the diodes themselves, so these are not your regular black diodes. These are probably going to look more like Schottky diodes almost. But I can guarantee that these are just a different packaging of them. They're going to have one side that is black. Let me see if I can try to get it in the reflection there. So the side that's black is going to be facing downwards. And then when you go ahead and solder these in, go ahead and take them, I don't know, a couple of millimeters out from each side, and you can just bend them straight down. So you get a shape like that. And you're going to be doing that for all 8 of the diodes. They're marked pretty clear on here. It'll be from D1 to D8. So when you go ahead and put them in, I guess I can also get a little bit more light from this side. I'll zoom in here. So they're going to be looking like that. And you can see the little black line. Maybe you can see it, get it in the right light. The little black line is going to be facing the bottom of the board. So go ahead and we'll just do the one to start, and I'll show you how to solder it. And then I'll give you guys a couple of minutes to go ahead and solder the rest on your own. So we'll go ahead and just flip the board upside down. And this just allows us to put pressure on that diode so that the pins stick straight up. So you might want to put like a weight or something. So here I've got like a little computer dongle. I'll go ahead and just put it on the one side to keep it weighted down so it's not going to move around. I'm also using a silicone pad, which helps. It's a little bit heat resistant, so you're not scratching up your tables. Hopefully you guys in your dorms aren't doing this on a surface where you could damage it. Make sure you get your security deposits back. But go ahead and take out some solder. So I have mine on a little spool, but some of you today and yesterday, I gave some lengths of solder. You're not going to need all of that, but take it out so you have probably about the length of your thumb, just so you're holding it far enough away from your hand and you don't burn your hand. My soldering iron's already heated up, so I'm going to go ahead and start by soldering this first diode on here. Let me just go ahead and clean it off real quick. So do we have anybody in here who has not soldered yet, actually? Oh my gosh. There we go. Anybody who is not soldered, who's currently working on this with us? Sweet. Everybody's giving me stares, so I'm hoping that everybody at least has soldered once or twice before. What you're going to do is you're going to start by taking your hot soldering iron. So my soldering iron goes up to 8. Why it's not 10, I'm not quite sure, but it goes up to 8, and I have it at about 6.5 to 7. So that should be plenty hot. And then we're going to go ahead and take the soldering iron and gently press it to one of those vias that you have. And you're going to leave it there for probably 2 or 3 seconds, and then go ahead and touch the soldering pad with your solder. It should really only take about half a second to heat up. And you're going to go ahead and put enough solder on there so it looks kind of like a Hershey Kiss, like the top of a Hershey Kiss. Let me see if I can get a good view of this. It may be a bit small to see. So you see there, it's really not sticking up very much. I probably could afford to put a little bit more solder on. And it's this top hole here. I'm aware the lighting is making it a little bit hard to see. But you'll just put just enough. And then you might see what looks like a kind of a liquid around the pin. That's not actually liquid. It's not conductive. It's going to be the flux that's the core of the solder. So sometimes you'll see on here like, so this is rosin. Oops, I guess it's the wrong way around for you guys. Or is it the right way around? Yeah, it's the right way around. This is rosin core solder. So it just means there's a little bit of rosin or a little bit of flux in the middle of it to help the solder flow a little bit more easily. So then once you've soldered the one side, we're going to go ahead and do the other. And then I'll give you guys about 5 or 6 minutes to do the rest on your own. These little guys are pretty quick. They really don't take all that much solder. And with only 2 pins, they're relatively easy as well. So like I said, just go ahead and touch the pad, and then go ahead and touch the solder to the pad. I'll go ahead and add a little bit more to that top one. And add just enough so that it fills in the hole and comes up ever so slightly. Let's see if I can get another look at that. So does anybody have questions so far with this? It looks like everybody's hard at work soldering. Everybody's got their heads down. Everybody who has a kit. But yeah, I'm sure Mike, Alexi, and Paul, this will probably take you back to your days in school if you guys did any soldering projects.
I am soldering a bunch right now on a project I'm working on for the.
Oh yeah.
So yeah.
Yeah, I'm sure you're all too familiar with the smell of the solder.
Yep, I worked hard at it today. So.
Oh gosh, yeah. We've done quite a few soldering projects with IEEE, but this is probably the most intensive soldering project we've done in a while. We had one over the winter holiday that was a Christmas ornament. Here, I'll go ahead and we'll call it a holiday ornament. But yeah, this was a soldering adventure, and a lot of people actually had their first experience with soldering surface mount parts with this. They're a bunch of little surface mount resistors. Oh, I keep forgetting I'm holding this. It's mirrored for me. But so this was a lot of people's first experience soldering surface mount parts, and we had the president of our club gave this to her dad as a kit. And so they were soldering it together, and her dad managed to completely rip up one of the vias going all the way to this center thing. So that was definitely an interesting picture to receive one evening. I don't know if I've ever seen that before. But. So for everybody else who's following along with their kits, you're just going to go ahead and do that same thing for all of these diodes. What I typically do is put them all in the correct way. Make sure you're putting them in the correct way. And then once you have them all in, you can just kind of, hold your hand over it, flip it over onto the back so all of the leads are sticking up, and then just go ahead and solder them one by one. It also helps to hold the soldering iron in your dominant hand. Typically, if you hold it in your non-dominant hand, it's going to be a little bit shaky. But we'll go ahead and do all of those. And like I said, the footprints should kind of guide you to put it in the right way. One side, there's going to be a black line. The other side is just going to be orange. So go ahead and just put those all in there. And I'll ask this again. Does anybody not have parts? Is anybody missing components, missing parts at all? Okay, this is one of those times where head shakes are good. If I saw head nods, I'd be a little concerned. So also for our Roden Schwartz people, this is actually one of the pillars of IEEE are these technical workshops. So for example, we're kind of focusing pretty heavily on some soldering workshops. We had that Christmas ornament, and then we have this one. A lot of freshmen or early sophomores, typically they have a class, it's EE 210 here, and they do a soldering project. But unfortunately, last year, because of COVID, a lot of people didn't get to do that project. So their first experience soldering was our winter ornament workshop, which, had I realized that at the time, I probably wouldn't have put surface mount parts on it. But I'm sure we have some freshmen and sophomores out there that are real good at soldering now. But yeah, it's this whole online hybrid course structure isn't great for the in-person labs where you get to learn in-person skills like this, or hands-on skills. And it's also nice to hear that you had mentioned soft skills tonight, Mike. We partnered with DigiKey last Friday, and they hosted a nice little webinar on project management, which I don't believe I have ever heard the words project management since my freshman year, whenever we had to take an engineering design course. And they talk about project management for all of 5 minutes. And yeah, so those soft skills really aren't taught in our mainline courses. So it's nice to have presentations, especially from companies like you guys, that go over the importance of those, quote unquote, soft skills.
Hey, Ethan, I appreciate that feedback, but I'm actually tremendously impressed with your ability to multitask, talk, and run a meeting while you're soldering. That's pretty good.
See, I would attribute that to my own gained skills over the years, but I think it's just my ADHD keeping me going in multiple things at once. So we have Will and Muchin, who are members of my projects committee, and they'll see me doing stuff or like working on a PowerPoint or something and just kind of rambling while I do it.
Can confirm.
So has anybody finished with this yet? Has anybody finished with the diodes, I'll say? Okay, Will, I would hope you'd be finished with these. You've had a couple of weeks to work on this, so. All right, Sarah says she's done. So there we go. If you have wire strippers or some sort of clippers, I would recommend taking down these on the back. If you're really in a bind, scissors will work, but make sure you get it close to the handles on the scissors and try to just do one at a time. I would recommend clippers like this. I would imagine that most people in EE have gotten these in a kit or have acquired these kind of on their own at some point. But these are a nice tool to have. I got these with my 3D printer. So go ahead and snip them off. You do want to leave a little bit of a nub there in case you ever need to come back and kind of resolder something or push it out. It's always nice to have it that way. Also, I'm just double checking my work to make sure I put them all in the right way. My multitasking works most of the time, but okay, it looks like I got them all correctly. So here's one of the instances where I probably needed to add a little bit more solder to this. The solder kind of fell through the hole a little bit while I was soldering it. So I'm going to try to hit it again here. There we go. Some of you may also have a little sponge with your soldering iron. So this is to get off some of the old crusty solder that if you've been soldering for a while, typically you'd have this like in a little dish. But so I have some solder on the tip of my iron that, maybe the flux has burned off and it's not reflowing very well. When this is wet, of course, you can go ahead and run it over it a couple of times and it'll ball up the solder and collect it in here. So that you can get some fresh solder on the tip of your soldering iron. I'll go ahead and finish clipping these off. I'll go ahead and mute myself so you guys don't hear me snipping away. So there we go. You can see kind of how there are still little bits on the bottom there. And like I said, that's important if you ever need to come back, especially if you're prototyping, because Will and I have gone through a ton of prototypes for these. If you're prototyping, it's nice to be able to have those there. So you heat up the pad and then use something like these snippers or the end of the soldering iron to kind of push it back through. So they're still flush with the front, but they have that little bit of nub sticking out the back. Not too much. And if you cut them the right way, they shouldn't be too sharp. But don't worry about these sticking out from the bottom of your board. You will notice that you got some feet here. Don't put these on just yet. But at the end, it'll just kind of prop it up off of the desk. So if you were to use this on a conductive surface, you're not going to interfere with the contacts. So actually, the next part of this is a little bit awkward to say. Oh, and I'll flip this around the correct way for you guys. So in the design of this, like I had mentioned earlier, I had intended to have a MOSFET to drive the LEDs that are going to be backlighting the keys here. So during the purchase portion of this, I ended up getting the wrong type of MOSFETs. So you'll see there's actually a tiny little space here. Let's see if this focuses. Yeah, there we go. There's a tiny little space here that for a surface mount part. So that was supposed to be a MOSFET. And there were two resistors going from this to, I believe it was to ground. And then the other one was going to the LEDs. But the way that this worked out, we're actually able to straight power it from one of the pins. The LEDs don't consume too much power, and they're just little guys. So we'll go ahead and wire this up a little bit of a different way. So when you're bending the leads of your resistor, so now is about the time to get out your resistor. We're going to be using a 470 ohm resistor. I found that it works best. It's not going to allow too much current to flow, so we're not going to burn out the chip. But it'll be just enough that you can see how bright the LEDs are. So when you bend this, make sure to bend this a little bit wider than what you bent the diodes. Because instead of going across, so don't follow these, instead of going across, we're actually going to go diagonally. So you're going to take your resistor and kind of push it in like this. I'm going to actually have to bend the leads a little bit. Hold on. A little bit more. A little bit too ambitious with how wide I made that. So your resistor is going to go across like this. And it's important to have it in this direction. The other direction won't work. And I'll just double check my own work here. Make sure I'm doing this the right way. Yeah, there we go. So you're going to want it to end up looking like this. Oh man, keycaps are in the way. Right like that.
If you don't plan on, oh, sorry, you go ahead.
Is the yellow, I can't really see it in the camera, but is the yellow band in like the R2 end of it?
So resistors don't have to go in a certain way. They're not directional devices.
I was just making sure. I knew that.
Yeah. So if you're looking at it from your way, you're going to be going from the bottom right to the top left. So does anybody have questions on this part? And you're going to solder this in just like you soldered in the diodes. Just want to make sure everybody gets this the right way, or else you won't have those nice little backlit keys. Ryan, it looks like you're inspecting your work. How's it going?
It's going good. I got it. Got it all set up here.
There you go. Nice. So yeah, I'll go ahead and flip this over, and we'll go ahead and solder this up as well. Also, if you're concerned about, like I said, that little bit of flux, you can kind of see it in the reflection here, that little bit of flux around the pins, what you can do is you can get a Q-tip or a little piece of paper towel and dip it in some isopropyl alcohol, and this should wipe up right away. Typically, after a few hours, it'll like harden almost or get kind of sticky. So if this is something you're doing as a gift, you might want to go ahead and clean it up. It's not going to be seen very much since it's on the bottom side. But you know, I know it's going to be there, so I'll probably clean it up eventually. Snip that a little bit more. All right. So the next step is going to be the big ones. You'll go ahead and take out whatever key switches you got. So I just decided to use yellows for mine because my other little demo board over here has some browns. But you can go ahead and pop these out. And Will wanted me to mention. So as robust as these little keycaps are, I mean, they're made out of some pretty strong plastic. But the leads on the bottom, the metal leads on the bottom, let's see if I can get this to focus. There we go. So the little metal leads on the bottom, you can see like on this one, the one is curved a little bit. So you want to straighten that out and make sure that that they're going straight on.
Yeah, it may not be curved on yours, but due to the way that they were shipped, some of them may have bent. Just be careful with them because of they can be a little fragile, but it should be fine if you gently bend them out.
So this is going to be the most important part of them. You'll see that these other pegs sticking out are just plastic, and these are what are going to grip it onto the PCB itself. So although we have these connections over here, the big ones you'll see, as much as we have those, the plastic is going to be what's structurally holding it onto here, and the contacts are just going to be the electrical contacts. So again, these look kind of fancy, but they're really not much different than some other switches that you might have used on a breadboard. So let me find an example of one of those in my stuff over here. So here, I got a whole box of tactile switches. So you might have seen like something like this. Hear that nice little click there. So this really isn't much different from these key switches. It's an internal switch that when pressed, you know, it connects some terminals, and when you let it go, it disconnects the terminals. So it's going to be the same for these. That's why we really only have those two pins. And if you look, oops, out of frame. That's why we're only going to have these two big pins up top. And if you look, it has the symbol for a switch in between them. You'll also see that there's a plus and minus down below. You can ignore those for now. Those are going to be for the LEDs once we get these switches in. So when you go to put the switches in, obviously you want to make sure you're orienting them the right way here. So the holes should line up. You know, go ahead and just kind of put them into the holes. But this is where the scary part is. You have to apply a good deal of force to get them to snap into place. I see Ryan's already flexing his finger muscles there. But yeah, I had to apply some serious force to get this in there. It's just due to the tolerances in the PCB manufacturing. I mean, we get these things from JLC PCB. So the tolerances aren't super, super sharp. So some of these holes may be a little bit easier to get into than others. But at least for this key switch in this hole, it took quite a bit of pressure to put that in there. And then rather than soldering these, you know, you stick it in, solder it, stick in the next one, we're going to do the same thing that we did for the diodes and put as many of these in as we can. I'm just going to put all 8 in and then solder them up all at the same time. Does anybody already have their key switches pressed into the board?
I just want to make a quick note. It really is important that you have the plastic touching that, so you can really, really go ham on these things. You may want to check your key switches by putting it up against the light and seeing what light comes through in between the PCB and the switch, just to make sure that it's fully pressed up against the PCB.
Is anybody having issues with this step so far? So for example here, I actually, oops, I keep going off screen there. This one that I just pushed in took no effort at all. It just kind of slid right in. So for whatever reason, whether it was the key switch itself or the manufacturer tolerance on the PCB, just went straight in, no problem. This one, on the other hand, is giving me a little bit more difficulty. And don't be afraid to push pretty hard on the key switch part itself. I usually just use my thumb and push straight down.
Yeah, if you push the actual, it's called the stem, the colored part of the switch will not hit the bottom, so you don't have to worry about it.
Yep, so looking at this, looks pretty good. you can see that there's really no gap between the switches and the printed circuit board there. Okay, maybe for this one, I'll have to clean that one up. But Will had mentioned earlier that most keyboards are not made this way. You'll really only see custom boards or custom Macropads made this way, soldered directly onto the PCB. Most of them use a little hot swap thing, so you can just push the switch in and then take it out at any point. And the hot swap little carrier is what's actually soldered in. So you could take these in and out at will.
I also wanted to mention for boards that are soldered, I have a soldered board right here. You can see it's actually kind of like a sandwich. I don't know if you can see that. There's a bottom part, a top part, and then the PCB is sandwiched in between. The top part, the switches click in so that you don't put any stress on the solder connections.
So is everyone pretty much done with pushing them in, maybe starting to solder? So one of the things that you'll notice with the key switches that you didn't have to do at all with the diodes and the resistor is you're really going to have to use a lot of solder. Basically, each one of these holes takes about a 1/2 inch to 1 inch of solder, which is way more than what you would use on any of your other through-hole parts. And it's just because these holes are so much larger. Let me get another close-up there for those who don't have kits in front of them. I know it's upside down, but they're just so much larger than the other pinholes on the side. So you not only need to fill it up, but also put in enough solder to have it kind of come up a little bit, just like we did for the others. So kind of that almost Hershey Kiss looking shape. I'll go ahead and solder these. It also might help to do the middle ones first because you can push straight down and all of the stems on the key switches will go in. So there, that used a ton of solder. That was probably a whole inch of solder. So that's why those who had picked up soldering irons from me, that's why I gave you so much solder. Might have seemed like a ridiculous amount at that time, but you'll chew through it in this stage. Go have to get some more out. Oop, almost burned my fingers there. I think it goes without saying, please be careful. Make sure you never touch the metal part of the soldering iron. You can tell with the smoke coming off, it's probably not a fun time. Also, Amelia, do you have a soldering iron?
No, I don't.
I should have given you one. I actually have an extra one here in my apartment.
It's
Well-
okay. I'm going home next week and I have one at home, and my dad likes this stuff too, so I was gonna do it with him or show him at least some of it.
There you go. That'll be fun.
Yeah.
I'd forgotten that you had said that you were going to be going home and just doing it then.
Yeah. Plus I have a Windows at home, so I think it might be better than doing it on a Mac. So I was gonna try and
That's right. We had that conversation.
yeah.
An EE with a Mac. Imagine that.
It's challenging at times, but I like Macs better, so I'll take it.
I guess also if you grew up with it, it's probably a little bit easier to use. All right. So I know I might have done this a little bit quicker than some of the others here. People I haven't checked in with recently. So Muchin and Andrew, what are your statuses? Also Antonio as well. I don't know if you guys are still following along. How's it looking?
Got 2 keycaps left.
Oh, nice. Okay.
Yeah, I'm doing well. I actually got my video enabled because I'm on boot camp and doesn't recognize my camera.
Oh gosh.
Yeah, I'm doing good. I'm with Amelia. I'm a Mac person.
Gosh. All right. You guys can bond over not being able to install programs that we need.
Well, it was good up until like we went virtual and they closed all the computer labs. So
Yeah.
it's fine.
I should note though that I did a little research, and apparently QMK Toolbox, which is the software we're going to use to upload the firmware, apparently is available for Mac. So
Do you want to share that link, Will, just so we
the
have it?
link
And then
is in the gist. If you look,
okay.
If you look at the gist and go down to flashing the firmware, if you go to the Windows instructions, there's a link to QMK Toolbox.
Okay, nice. So then I'll give everybody another minute or so. And then we'll get on to the last few parts that need soldered. But for those of you who are already at this point that you have stuff soldered in, I wouldn't recommend putting the keycaps on just yet. They're going to increase the height of everything, and just at least for this one part, and especially because if you want to put the LEDs on, you're going to need the keycaps off. So we just used some standard white keycaps. These are quite literally a dime a dozen. They look pretty sharp, I say. So if you're at that point, what you're going to do is you'll see a set of female pin headers. You should have 2 of these. And what you're going to do is put them onto the pins on the bottom. I believe there are 12 on each side. It looks like 12 from my quick counting. So go ahead and put these on. If your pins are bent, so actually the one pin on this is a little bit bent, you may have to put it on a little bit differently. I think this is bent just because I've been messing around with it. Actually, I'll pull out another set of these just so I don't have to fidget around. So here we go. I have them on my Elite C, which is just it's a more expensive version than the boards that you guys have. It has a different type of bootloader on there, and then it also just has a USB Type-C port, which I have a lot of these kinds of cables, so I like these a little bit better. But you should have gotten a cable in your kit that will connect to the Pro Micros that everybody else has. So I'm just using this because this does not have bent pins. But when you go to put this on, so I guess I will still keep it this way so it's right way up for you guys. You're going to go ahead and put these in the pin slots so that the connector is pointing up. Is everybody at this point now? Perfect. Head nods are always welcome. All right. So for this, I would just recommend flipping it over. If you have some problems where the pins are moving around a little bit, you may want to apply some force while you're soldering, but you're just going to do what you did with all the rest of these and hit them all with a little bit of solder on the way down on both sides. The pro tip for this is to solder one corner of the board. So soldering it down like that. I'm just going to apply some pressure so that it doesn't jump back up. And then also solder the opposite corner. Once you have those in, it shouldn't wiggle around anymore. So just for a closer visual inspection here, you'll notice that I soldered, so it's going to be I guess it's bottom left. Like I said, everything's mirrored, and the top right. For me, at least, that's what it is. And then once you've done that, like I said, just go back through, put a dab of solder on all of those. This should take, honestly, the least amount of time out of everything, just because you're going down, touching it with the solder. Next one, touch it with the solder. So Mike, also this was the struggle of this past couple of weeks, and the reason that this workshop had been rescheduled a couple of times was because of Penn State's rules about reserving rooms during the hybrid phase that they have going on. They wouldn't allow us to reserve the rooms that we typically use, which are really the only rooms that would fit a group of our size right now with all the COVID occupancy restrictions. So we had to reschedule it a couple of times. The first time was because I forgot that it was the Chinese New Year and all of the parts that I had ordered were on hold. And the second time was Penn State not allowing us to have the workshop, which is unfortunate, but hopefully in the next couple of weeks we can be back in person full time for these workshops, or at least hybrid, because I do want to still allow that online stuff. Oh yeah, so Ethan B in the chat said, wasn't the one room reserved for spiritual gatherings only? Yeah, so I had tried to reserve a room in the Pascarilla Spiritual Center, and I had set it up as a workshop because those rooms were available, and I got an email back saying that we couldn't hold this type of event. When I asked for more clarification, they're like, well, is it a spiritual event that you're holding? And our president responded to my email, not in the CC email chain, thank goodness, but said soldering is my religion. So we got a laugh out of that. But yeah, so we've been fighting the good fight, trying to get back in person for our soldering adventures here. All right. Anybody else have the microcontroller soldered in? I see heads still down, so I'll take it as you guys are still working. So I'll give you a couple minutes. Fortunately, the programming aspect of this shouldn't take too long. I think the last time Will and I walked through it, it took 2 or 3 minutes. And that's after you have the configuration set up. But Will and I compiled a lot of the things ahead of time. So it should just be as easy as a copy and paste for all of you. I see some furrowed brows, especially from Sarah.
I had to step away for a second, but I do just want to clarify. Programming will take 2 or 3 minutes, but it may take a little bit longer for you to program, like make the firmware. Oh yeah, well, like I said, we have some of that stuff is pre-compiled, especially with the layout. Oh, Mike, your comment, customers who would abide by soldering as a religion, that and ham radio. Oh my goodness. So we had an intro to software-defined radio workshop last semester. And there's a small ham radio club here on campus. It's an amateur radio club here on campus. And the presenter that we had was very, shall I say, enthusiastic about his hobby. I find that a lot of people who work in ham radio, I tried to get into it whenever I was younger, but it's a little bit advanced as a high schooler, I found at least.
What was that about that furrowed brow comment?
I just saw you inspecting your little macro pad, and you looked extremely confused. So I
wasn't confused. I was just trying to see if all the holes were good, which I think they are.
Okay. Oh, I think I lost my camera again. Give me a sec.
I just said, who?
I'm going skiing tomorrow night, so I'm pretty excited for that.
Nice.
On Fridays.
Nice. Any reason for a class or something, or?
No, just for fun.
I respect that. I haven't been
Is it
snowboarding
Tussie?
for so long.
No, we're going to Blue Knob.
Where's that?
It's like past Altoona, I think, so it's like about an hour and 15 minutes away.
Nice.
Does anyone ski? I've only been once.
I've tried.
Oh yeah.
I broke my roommate's phone trying to ski.
I just learned how to snowboard at Tussie, and it is like the shittiest mountain ever. It's like ice.
Oh wow.
Yeah.
I used to do snowboard competitions in high school.
No way.
Yeah, Ethan is our resident snowboarding expert.
Yeah, I would do all like the rails and the jumps and everything.
Yeah, no, I couldn't even dream of that right now. I'm trying to learn how to get the toe turns down so I don't keep away.
Yeah, it's the toughest part. Especially, see, it's easy when you're like 13 and you're learning.
Right.
It's like after a certain point, it's like learning a new language.
Yeah, no, it's tough.
All right, you guys want to keep chugging along here? Is anybody not ready to move on to the next step? See Andrew inspecting his work. So, all right, so we'll go ahead and move on. So the next part of this is going to be adding the LEDs. Some of you have some blue LEDs, some of you have whites. I believe Amelia got the special ultraviolet ones. So those are an officer exclusive. Anyway, we'll go ahead and put these in. When you're slotting them in here, I know we had covered up the,
Hey, Ethan, I'm not sure if you're saying something, but if you are muted.
I could hear you.
We good?
Yeah, I can hear you.
Hey, Will, you sure you're not
Okay.
muted? Or you're not deafened? I don't think Will can hear anything. Here, let me, it's on your end. There we go. All right. Everybody else can hear me though, right? We're good to go? Okay, cool. So I'm gonna grab another PCB here and I'll show you guys what I'm talking about as far as the orientation of the LEDs. Because remember, these do have to go in a certain way. But while I'm doing that, go ahead and pour out your LEDs. You should have 8 of these, 1 per switch. All right. So just kind of overlaying this here. Oh, those fit nicely inside. So you'll see a plus and a minus on the bare PCB here. So I'll hold it up a little bit closer. I know you've already covered these up, but it's probably just better telling you the direction rather than having to remember them. So yes, the longer lead on your LEDs is going to be your positive. So it's going to be going on the left-hand side. So you'll notice that each of these key switches has a tiny little hole in there and a little bit of a slit. So go ahead and put your LED through. Might take some finagling, but if you go straight down through, it should fit. And you'll notice on the bottom, it should come out the bottom. Will, did you get your audio working there?
Yeah, sorry about that. I don't know.
All right. Sweet. We're gonna need you in a couple of minutes for your portion of this. So remember, the longer lead is going to go on the left, longer left, however you want to remember it. And you're just going to put an LED in for each of them. You may have to push down kind of hard. There's a little bit of a lip around the LEDs there. And the whole spacing actually in the keycap itself is a little bit small for these types of LEDs. but they should work no problem as long as you push them all the way through. So we're going to do the same thing that we did for all of our other 8x components and just put them through, solder them up. And again, that should be pretty quick. And once we've done that, you won't have to hear my voice for a little while, and you can hear the soothing voice of Will McGloughlin. Also, just because I encountered this on my own, I had an LED where the pins were a little bit bent. Helps to straighten them out. Should have mentioned that before. So like I said, this is part of the prototyping process that you can kind of see in action. Whenever I had said, you know, we going through this with all the best of intentions, if you order the wrong parts, but design for different parts than you order, you're not going to have a product that works exactly as intended. And I'm sure Mike could echo that with his background. You know, if you have one part of the supply chain that isn't working as intended, it kind of makes everything a little bit more difficult. Luckily, we were able to find that workaround with the resistor tucked in here, kind of angled, a little bit skewed there. But yeah, so make sure that whenever you're designing a project, either for a class or a project or product, even for whenever you go to your job, to make sure that you double, triple, quadruple check, make sure you have other people check your work when you're designing stuff. So for these, I'm just going to flip them upside down. You can kind of hold the LED in as you're soldering because it's not going to transfer the heat like a diode or a resistor will. The resistors tend to heat up pretty quickly, same with the diodes, just because they're so small. But there's plenty of plastic in between where you're soldering back here and where you're touching up top. You can kind of hold it in. Otherwise, if you just push it down all the way, you'll be able to get these LEDs pretty flush. And you'll want to get these LEDs as flush as you can because they will interfere if they're popped up like that. So make sure to get them in. And you can do these one at a time. I'm just choosing to do them all at the same time. Just a little bit impatient is all. So another thing that I just ran into is as I was soldering them, I had one of the LEDs, and just for example, this one right here that I'm working on has popped up a little bit higher than I'd liked. So I'm just going to put some pressure on it from the other side. I'll make sure to hold it where it's not going to be close to my fingers here. But you can heat up, if your soldering iron is a little bit wide, you can heat up both pins and then push it through as the solder is liquid. There you go. And it pops it right back down into place. All right. How's everybody's looking? Pretty good? Pretty clean? So this is another instance where you'll want to take some sort of trimmers, go onto the back, and just clip off those leads. You can do these two at a time, actually. They're pretty close together. Oops, just lost a couple of those behind my desk. Okay, these fly out everywhere. Maybe be careful. Might have wanted to require some eyewear protection for this workshop. You all signed the waivers, right? So here's another instance of where you want to have a little bit of nubs, going ahead and filling in some more solder from places where I didn't go as heavy with. And with that, you guys should be all ready to program these with Will's help. So yep, you can go ahead and slap on your keycaps. I won't because I have to use this for another demo in a couple of days. So go ahead. I will transfer it over to Will. Will, did you want me to pull up a slide or are you going to be sharing your screen?
I will be sharing my screen, but could you give me just a quick second? I'm having a bit of trouble here.
Yep. Anybody have questions so far? Can admire your handiwork a little bit.
I somehow soldered the end of the wire into the hole and it stuck there.
You mean the soldering wire?
Yeah.
Hopefully it comes out pretty easily.
I ripped it out. It seems fine.
Saying I ripped it out in the context of electronics probably is not something you want to find yourself saying very often. All right, so if you guys have everything hooked up, like I said, put on your key switches, and then with the cable included in your kit, go ahead and plug it in. I'm going to be using a different color cable. Like I said, I'm just using that other board that we had talked about. So you should hear a little chime on your computer when you do that. But while Will is still working, for those of you who are ready to move on to the next portion, go ahead and in that link that Will had sent in the chat earlier, it's the gist.github.com. Go ahead and open that up.
Yeah, sorry, I had to clear out my workspace a little bit.
That is a-okay. So once you have that opened up, if you scroll about halfway down the page under where it says flashing the firmware, you're going to click on the download and install QMK toolbox. Once you click on QMK toolbox, that'll take you to the download link. It's the same one that I sent in the email to those of you participating.
If you're using Mac, you can also, I think I mentioned, you should also be able to use QMK toolbox. If it's not available and I was wrong, you should be able to use the Linux instructions.
Mm-hmm.
Great. So while people are downloading that, if you want to go ahead and navigate to kbfirmware.com, it's on the gist under the Make the Firmware section. We will get started on making your Marcopad do what you want it to. I'm just going to post the link again in the chat, just in case anybody missed it. What can you guys see right now? Can you see two screens or just one?
We see your whole desktop, I believe, or we see the KB firmware builder and then the Pluto 8 setup.
Okay, do you see anything to the left of that?
No.
Okay, great. So I'm just going to have these up right next to each other. So I had mentioned that we needed to make a layout for QMK to build off of. We did that ahead of time for this 2x4 layout, and it's this right here in that little code box. So if you want to copy that and on kbfirmware.com, paste that in this text box, we can get started. If you have a more commercial QMK board, that looks great even. More commercial QMK board, it may, you can, as a manufacturer, send the layout to a GitHub repo that OLKB runs. People make QMK, and then it'll just be available whenever you want to make firmware using this firmware builder or others. But once you have that pasted in, let me see if I can see everybody here. Doesn't look like I can. Is everybody at the firmware builder, and does everybody have that pasted in?
Head nods, thumbs up.
Wait, just a second. So that, okay, so it's this first thing, and we're just putting it where?
If you go to kbfirmware.com, there's a link right above.
Got it.
Make the firmware.
Okay.
Post it in that box. Once you get there, if you go ahead and click import, while people are catching up, I'm just going to do a quick overview of what we're looking at here. So up top, you can see the layout and kind of a basic circuit diagram of what our keyboard looks like. You don't want to change this. 2 rows, 4 columns, that's all right. Column to row, that's all fine. Okay, I will keep that in mind even. That might be something, that might be something I can't really fix if I'm talking a little quiet, because that might just be my microphone, but I'll try to speak up. So if you go over to the pins menu, there's a whole bunch of stuff we have to change here, and I've listed that in the table right here. So I will give everyone a minute to change the row, column, and LED pins on the table here. We don't have an RGB strip in this version, but if you do want the backlight, you do need to have backlight set to D6.
So this is what we kind of talked about earlier whenever we were going through the schematic is there are different pins on here. So they're the Arduino pins that you might know. So like an Arduino Uno, all of the pins on there are listed as their Arduino pins, or what they show up as in the Arduino IDE. But because we're using a different firmware here, you'll see that there are different pins like D4, C6. It goes all the way to like E or F at that point. Those are just the different ports on the actual chip here. So you'll have like port B, which has 6 different pins allotted to it, or I believe doing the drop down here. So yeah, there are a few different ports. So those are on a hardware level describing what these pins are. So that's almost more of like a C or even maybe even an assembly language level, where you have to specify not only the IO port, but also the pin associated with that port. So think about a port as, a port has, let's say, 8 different digital pins associated with it. So you point to the port, which is this whole Marcopad, and then the pin. So that's the, D is this whole thing, and then 4 is this one over here. Something like that. That makes a little bit more sense.
Okay, so I've put all of the pins from the gist up in the pins tab on kbfirmware.com. Is everybody there? Thumbs up? Head nods? Great. So here comes the fun part. I'm going to kind of give you an overview of what you can do here, and then I'll let you loose for a couple minutes to get it to do what you want it to do. So there's 2 main tabs we're going to be working with to tell what we want it to do. Key map and macros. So let's start with key map. We're going to start with layer 0. We're going to just do 1 layer. If you're really interested in multiple layers, you can talk to me a little bit later, but we're going to focus on just 1 layer for now. So you can see right now all of the buttons are set up to just be the spacebar. If we compiled this and then uploaded it to our board, we would press every button and it would just be spacebar, spacebar, spacebar. So if we want to change one, we click on the one we want to change, and then click on the key code down here, and then it gives us a whole bunch of different things we can do. So you can see you have your alphanumerics here. I actually do not know what those are. But you have all of your normal keyboard keys. You have all your modifiers down here. TRNS is transparent. It just means that if you have multiple layers, which I'll talk about in a second, it will go to, it'll default to the key from the layer under it. We'll get to that in a second. Secondary, you just have your F keys. You have some of the things you would find on the shift layer, some of your symbols. Stuff you might find on the right of your keyboard, like the insert, home, delete, end. Keypad you can ignore for now, but lighting, so that's how we're going to tell QMK to control our backlight. Specifically BL tog, BL deck, BL ink, and BL step. So it's backlight toggle, turn it all the way on, all the way off. Decrement, make it not as bright. Increment, make it brighter. BL step. I recommend BL step just to get started. So I'm going to click on that, and BL step will be assigned to my top right. If you want to do macros, like I was talking about, like Control C, you can go to the macro tab, do record macro, and I'm just going to do Control C and stop recording. And you can see it made a list of actions that one macro would do. If you want to add that to a key, so you can see I'm modifying macro 0. If I go back to the key map, and let's say I want to assign it to this key, if you go to other, function, there's M, and then you select macro 0. And now that key is set up to be macro 0. If I want a different macro, I go to the macro tab, modify a different macro. I'm going to do one, and I'll make this one Control V. Record macro, Control V. Then I can go over to key map, make that M macro 1. So now that's Control V. This is done a little bit differently if you're using a commercial QMK board, but this should be enough to get you started for now. So you guys can go ahead and set some of those keys to be whatever you want. Very briefly, you can ignore me if you're not interested in layers, but I'm just going to briefly go over layers. If you go to key map and the function tab, there's a whole bunch of different QMK special functions here. Specifically, I'm just going to go to MO, and this just means momentary toggle to layer N. So if I go to layer 1, this key, when pressed, will go to layer 1, and then we can modify a different layer and then have a whole different layer, do a whole different set of things. So for example, if I set this one to something simple, the number 1, what this will do is, if we're on layer 0, and I click momentary layer 1, as long as I'm holding that key, it will all of the keys will be in layer 1 mode. So if I'm doing momentary layer 1 and press the 1 key, it'll be 1. But if I don't have that pressed down, in this key map at least, it'll just be layer 0, which is a space. And you can have a whole bunch of different layers. You can do a lot of really complicated stuff with QMK, which if you're interested, you can talk to me about. For example, you can have it so that if you tap it in a certain pattern, it goes to a different layer. Yeah, all of that stuff, I can't even remember everything you can do. All of that stuff is going to be in the function tab here. So like these are a bunch of different combinations of modifiers. These are all your layer toggle things. These are to toggle modifiers, and then M is your macro. So I am going to try to get a better view of it. But does anybody have any questions while they're setting up their key map?
How did you assign the macro to a specific key again once you make it?
Sure. So if I'm going to use macro 1 as an example. If you go over to keycap and you're on the layer that you want, you click on some key, click down here to change what that key does. Go to function, M for macro, and then select the macro you want it to be. So I selected macro 1, which is Control V for me.
Gotcha. Thank you.
Yep. And what I said about transparent, let me go to layer 1. You can see that all of these default to transparent. So if I click the go to layer 1 key I have, which is this one right here. If I click this one, it's transparent, so it defaults to the layer below it, which is space. So if I did momentary and then this key, it would be a space. If you have any questions, you can unmute yourself or you can type in the chat. I'm going to give it a couple more minutes, then I'll move on to how to flash.
And actually, I can cover the flashing tutorial on Windows.
Yeah, I'm on Linux, so unfortunately, I'm going to be doing it in kind of a weird way. But yeah, Ethan will take over from me. Another quick note, if you look at the settings tab over here, if you are using backlight step, which is BLST, I believe, you can change the number of levels that it steps through. It defaults to 3. I find that you don't really need any more than like 2, but yeah, you can change that here. It's also going to give you a bunch of warnings that you can ignore because we're not doing a full keyboard. We're doing just a small Marcopad. Also worth just noting, for more complicated and like really in-depth QMK layouts, there's actually like a whole scripting language you can play with here called Quantum. I haven't found a use for it yet, but you can do some really, really complicated and powerful macro stuff and layer switching. But I don't recommend touching any of this. So is anybody still stuck, or does everyone have a, give me a thumbs up if you have a layout that you're happy with and you're ready to move on to the next step.
All right, cool. It looks like there are a good amount of people.
Okay, great. So last step, once you're satisfied, you go to the compile tab and do download.hex. You can do download.zip if you want to compile it yourself, but download.hex is what we're going to use right now. go ahead and download that.
So I will take it from here. So I know that you can see my screen still. Hopefully you can still see this. Let me just make sure this is focused. We're going to do a couple of things before we get to the hardware side. I'm going to go ahead and share a portion of my screen here for a sec. Portion of screen share. Oh, that is the opposite portion of my screen that I wanted to share. All right, let's try. There we go. Can everybody see me in the KB firmware? All right, awesome. So I'm just going to show kind of what I had compiled here. I just want some basic QWE, and then this is the BL step key, and then ASDF. So I just basically have the top left corner of my alphanumerical keyboard up here. So obviously I go ahead, compile this download.hex. I don't know if you can see me moving around this little file here. I already downloaded it. You actually in the settings can name your layout. There's also a way to save the configuration. And this is just easier for you to upload the configuration later. It's kind of just a quick way to upload it when we had pasted in that little bit of code at the beginning that Will had showed us. So once you have that, I would encourage you to open up QMK Toolbox. So this is going to be, at least on Windows that I know of, is going to be the default way of uploading. So when it says MCU, this is going to be our microcontroller unit, and we're going to be using the Atmega 32U4. Most of the times it will default to this, but just to make sure, we'll go ahead and leave that as is. So there's also an option down here, keyboard from qmk.fm. So this is a repository online. And if you were to open this up, you could see, a bunch of different keyboards. Ours, unfortunately, is not on there yet. We plan on getting it up there at some point, but it would have basically all of the firmware already up and ready to go. And it just is kind of like a default layout. But we're going to go ahead and use a local file instead. So go ahead and hit open. And so I'm going to go to my desktop. I know that I had my little Pluto 8. Oh, did I screw this up? No, it's right here. Pluto8.hex. You can see all my games that I play as well. So we're going to go ahead and open Pluto8.hex. So you should see it in that little box there. Now, I find that one option here, so flash when ready, is the best way of doing this if you're just going to do like a one-time upload and you like how it's saved. Alternatively, on the back of this board, you'll see that I had pointed out these ground and reset pins at the very beginning of tonight's workshop. And these ground and reset pins, you could use some real advanced technology, such as here is part of the lead that we had clipped off. I don't know if this was from the resistor or from the diode, but I just clipped it off, folded it in half. So this is one continuous piece of metal. And if you jump these reset and ground pins, it will disconnect and reconnect. And it should flash when ready. Or no, sorry, you gotta tap it twice. My bad. So you have to tap it once to reset it and then tap it again pretty quick. And we'll go ahead and see. Oh, maybe it was the auto flash. My bad. Auto flash enabled. Okay, hold on. Wrong setting. So like I said, you tap it twice and it should take it into, here we go. It'll take it into programming mode. So you can hear my Windows system sounds going crazy right here. But so that was it programming. So now if I come back to it, it's probably not going to change the functionality. It should still have the same functionality, but let me go ahead and just open up like Notepad++ or something. So let's go just a new file. Go ahead and bring this over. So I should see as I hit this QWE and then the backlight step, which we'll check that out in just a second. And then ASDF. Perfect. You'll also notice, so if I go on a new line here, I have to use my other keyboard. If you hold the shift key, it actually functions just the same as a regular keyboard would, and you get the uppercase letters. So that's just kind of a neat feature that this is basically just identifying itself as a keyboard when you plug it in. I guess I can backspace there. So because this identifies as a keyboard, you can use it just as you would a normal keyboard. And that's why the QMK firmware that we had picked for this is just, it's way more advanced than we give it credit. It basically emulates any key, any macro, any backlight toggle that you would like. So what I'll do is I'll stop sharing my screen here. There we go. Mike, thank you so much for joining. Really do appreciate you sticking around and also giving your presentation tonight. I'll make sure to share those slides and share the recording. And if there are any questions after the fact, oh, I guess he just dropped off. And Alexi, same to you. Thank you so much. All right. Sweet. Now that we're free from prying eyes. No, I'm just kidding. I'll go ahead and turn off my lights here. So it's kind of dark. And of course, this will be way more dramatic than if you had your lights on. But hitting this BL step, so you'll see it's very, very faint. But as I hit it and it goes up to full brightness, you can go ahead and see it illuminating there. So it looks a little bit different if you have the white LEDs as well. So all I theoretically have to do is plug this in. So I have another board pre-made here, of course. But I'll go ahead and plug this one in, and you can see what the white LEDs look like. There you go. So there are the white LEDs. And Sarah, or no, I guess it was Amelia that got the ultraviolet ones. I'll be curious to see what those look like in a couple of weeks. Make sure you post that on the Discord. I think that'll be kind of cool.
Yeah, I'll definitely send pictures of it once I get it finished. Yeah.
So that's that as far as the physical build. The last thing there is to do, if you'd like to do it, there are just some rubberized feet that we included in the kit. I'll show you how I laid them out on this. So the top right one, I guess, for you guys, is going to be kind of overlapping one of the pins. So you might need to trim that pin down on your key switch, but the rest of them should go on pretty neatly. This one, I threw it in the middle. It does not affect the stability at all. Just there isn't enough room up here in the corner, and we would hate to block the reset and ground pins there. So this is just how I set it. I put one in each corner. The one side of them is sticky. The other is not. It's just rubberized.